All right, so today I'm going to be doing a code walkthrough for my summer project that I've been working on this summer with Professor Kate Compton for a research project. So this is a code walkthrough for my collaborative mentor project, and this is all on GitHub. So if any of you have any questions as I go through this, feel free to ask. So here's how we're going to go through it. We have an overview of the project, and then I'm going to go more in depth with the back end and then the front end. So this is I call it a collaborative mentor. The reason I call it that is because it creates non-fungible tokens, NFTs, which are these digital collectibles, and it does it in a turn-by-turn manner. So here, this is the output of one of my user tests. So first, we had the first person create this first stage of the project, and then it was sent to user number 2, and user number 2 created this version and uploaded it, and then it came back to user number 1 and they created this version, and then this was the final output. So really each of these is an NFT, a digital collectible that can be traded or sold. It's a piece of artwork that's on the blockchain, and you can also see how there's value in the sequence. So there's two aspects of that. So this is what it looks like on a marketplace. So OpenSea is a non-fungible token marketplace, NFTs. That's where you can trade and sell NFTs. And so, for example, the final NFT, Folly of Man here. Well, here we see, okay, the user was able to add the name. They were able to, well, this has a description. So you see here, it says this stage of the artwork was submitted by, and then it had the address of the artist. Yeah. So you can see that it includes this metadata of the description and also the name. And also you can see here that this is collaborative mint v3. So there's multiple minters that are made. All right, cool. So now I'm going to go into a demonstration showing the interface and how that looks like. So here I have this pulled up on my local server, and you can see here instantly. So yeah, the interface is pretty rough right now since it's just done for research and development, but right now it has my user address. So you can see here that if I show you my MetaMask, can you all see my MetaMask?
Yes.
Nice. Yeah, so you can see here, okay, so it's reading my account. And then you'll notice that this is on Wikibee test network. Well, I'm not using actual Ethereum at the moment to run this, so I just have it in a test network. And then you can see here that has connected factory contract. So if I were to put a factory contract, I'll get into what that is more later. But essentially, this collaborative minter are unique to the groups of artists that are working on it. So every time a group wants to create a new collaboration, they have to create a new collaborative minter, and they do that through the factory. So let me pull up the factory contract. So I've already deployed this before. So you can see here, well, it did some validation, and it actually added the factory address. And now if I wanted to make a new game, then what I could do is I could create a co-minter. For example, in this case, I'm saying I want to create a co-minter where I am both user 1 and user 2. Now this could be different users. And then it'll instantly on my MetaMask say, okay, do you want to authenticate a transaction? Authorize this transaction. And I can confirm. Okay, in this case, I am getting an error at the moment. Let's see, valid transaction envelope. That's actually kind of weird. I'm not really sure what's going on there at the moment. It's been a while since I've done some testing, but yeah, it should be working. But let's imagine that I had already created the co-minter contract. So this is what I can do with this one. So it'll actually, yeah, it'll add it. And then if I want to load the co-minter, see how it says beginning to display token URIs. So right now it's going to read off of the database for the images. So in this case, I actually did this on IPFS. IPFS is interplanetary file system. And it's a peer-to-peer file system protocol where you can upload your files. And what I did on the blockchain is I stored a link to those files, which are the URIs. Now it actually takes a while for it to read the database, but let's pretend that it had actually displayed the output. So it would have displayed each of these images. And then this section is still a work in progress. So what's going on here is, okay, well, sorry. The part starting at merge is actually a work in progress. The rest of it has been tested. So submit to the commenter. So this is where actually you would submit the next piece of artwork. So let's pretend that we're the user here, and we've just been sent this piece of artwork, and now on our computer, we have this file on our computer and we're going to upload that. Well, that's what we could do over here. We have this process of uploading the file from our computer, naming it, giving it a description, submitting. Notice that it says turn. So this will actually read to see, okay, whose turn is it? And if it's your turn, it'll allow you to submit the next file. It'll create the NFT on your behalf. And then this section down here, it's not functional yet. It's a work in progress. I'm still working on this project. But it's one idea is, for example, imagine that you're an artist and you've created a sequence of NFTs. So now you have NFT 1, 0, 1, 2, 3. So one idea is maybe you don't want them all separate. Maybe you just want one sequence of NFT. Maybe you just want the finished product to just be one NFT. And so what this merge NFT does is it actually goes through and it burns each individual NFT, and it creates a composite NFT, which is just one NFT showing the whole product. That's still a work in progress, but that's one idea, which it might be more valuable to collectors if we just have one NFT as opposed to individual pieces. And then what's going on here is managing the transactions. So there's actually a sales transactions component to this. So here you see that we can confirm transactions, deny transactions, or revoke transactions, depending on whatever transaction ID we want to work on. And we can actually create transactions. So this is basically saying, okay, who's going to, let's pretend that we have this piece of artwork and I'm only interested in the original on the first stage. So what I could do is I could say, okay, I want to place a bid for this first NFT. So then I would go back here and then I would say, okay, I want to receive it. So I'm going to put in my address. And then I'm going to say, I'm putting a bid in for 0. And then the idea is you can create the transaction and that's going to allow you to place a bid. So it's just still a work in progress. So I may have another text box that says, how much do you want to pay for that NFT? And then you'll be able to submit that. And so what's going on is that when you have a transaction, it's asynchronous to where the owners of the NFT have to approve that transaction for it to go on. So think of like a bidding system. So artists are able to say, okay, I'm an artist, so I like this bid, so I'm going to confirm that sales transaction and I'm going to allow you to purchase this first NFT. Or let's pretend that you change your mind and you submitted that transaction, but you don't want that transaction anymore. Then you can actually just revoke that as a sender of the original transaction. And let's pretend that you're an artist and you approve the transaction, you confirm the transaction, but then you change your mind. You can also deny that transaction. And then there's also this aspect of secondary sales. So normally one selling point of NFTs for artists is the idea of being able to get secondary sales, or like, let's say a 10% cut, for example, from any secondary sales on your NFTs. So this is allowing you to make that transfer. And then message log was showing just messages to the user as it progresses. All right, so that's a demonstration of the interface. Any questions so far?
Yeah, so when a user like submit to a committer, like to a file, yeah, so I'm wondering like, do they need to download the previous art from the like previous artist and then like modify the file and then resubmit that? Because
Yeah,
like
yeah.
they
So the way it works is that this load commenter function is going to show you all the previous turns on the page. So you can imagine that, let's say that I'm the artist and this is the latest output. So it's going to show me stage 1, stage 2, stage 3 on the screen. And then from the screen, well, it would have read everything from IPFS and rendered it on the screen. Then you'd be able to download it to your computer. And for example, in my user testing, we were doing everything on Microsoft Paint and then editing the pictures that way. But for example, if you use Photoshop or use some other editing software, then you'd be able to do that and then upload the file. So the images are rendered on screen for you to be able to download from the web page.
Okay, yeah, that makes sense.
Any other questions?
Gilberto, could you quickly explain what Minter is? Is it the actual NFT or is it the collaborator or something else?
Yeah, so the collaborative minter, essentially what it is it's a smart contract that allows you to create NFTs with other artists. So it's a smart contract on the blockchain that allows you to generate new NFTs in a turn-based way. And then there's a factory. So the factory, we can think about that as whenever you want to start a new collaboration, then you need to start a new specific collaborative minter for the specific artist group that you're working with. And then based off of that, the collaborative minter on the blockchain is going to create these non-fungible tokens, and then those are going to be on the blockchain as well. So I'm going to go a little bit more in detail into the code, and then you're going to see exactly what collaborative minter is versus collaborative minter factory. But does that help?
Yeah, that helps.
All right, cool. Any other questions before I go on? All right, cool. So we'll go on from there. So yeah, there's basically 3 main files to this project that are key and essential. So here we have a factory, and then we have the actual collaborative minter, and then we have the front end, which is a JavaScript file, app.js. So first we're going to talk about the factory. So really the goal of the factory is to deploy the collaborative minters, and it's also going to hold all the addresses of deployed collaborative minters. So you can think about collaborative minters as collaborations. And they're all going to be on the blockchain. So let's take a look at the code. All right, collaborative minter factory. So you'll see here, this is all Solidity. This is working with Ethereum, and we're importing collaborative minter. And the reason we're doing that is because this collaborative minter factory is going to create collaborative minters, and so it needs to import that file for it to know what collaborative minters are. And so here we have so you can notice our public array of addresses. So these are going to be all the different addresses of the collaborative minter deployments. And then we're also going to hold, okay, account to co-minter. So let's pretend that you want to know whether a particular artist is a part of any collaborative minters, and this will tell you this will tell you which minters are a part of. So here, the constructor, we don't really need to do anything, which is why it's empty. But what we have here is our create collaborative minters. This is the main function that's being called in our interface. I can show you on our interface, we have create co-minter. So that button is attached to a call to this create collaborative minter function. And you notice here that it takes in an array of addresses, which are the owners. So these are the artists that are working on the project together. And it's going to return the address to the collaborative minter smart contract in the blockchain. And so we're going to create a new new instance of the collaborative Minter smart contract, and then we're going to push the address of the new collaborative Minter to our public array. And then for each owner, we're going to update our mapping just so that we know that somebody is that all the owners have a corresponding co-minter, collaborative minter. And then we're going to return the latest collaborative minter that we just created, the address to that. Sorry, not the address, the actual collaborative minter. Yes, the address. My apologies. Okay, and we also have this get number of collaborative minters. So this is just saying, for example, how many collaborative minters has an account been a part of. So let's pretend I'm a famous artist. Maybe I've been on 5 collaborative minters, and that's going to make it easier for me to figure out and identify which co-minter I actually care about. Any questions so far about this collaborative minter factory?
So in this case, which one is the factory address?
Which one is the factory address? So whenever I launched this, for example, my migrations.sol, like I'm launching this from my particular my computer or my system onto the blockchain itself, and with the help, in this case, I'm doing it with Truffle. And so actually, I don't have a list of the collaborative minter factory's address itself. I would need to pull that from whenever I deploy to Truffle. And then Truffle would tell me, okay, I deployed your collaborative minter factory to the blockchain. Here's where here's the address.
Okay, yeah.
Yeah, if I wanted to, I could make, I could also make a public address, which is the collaborative minter factory address for easy reference. But honestly, since it's going to be easily available for me, I didn't decide to do that. Any other questions about the factory before I move on? All right, cool. So we'll move on. So the collaborative minter is a little bit more complicated, so we're gonna go step by step. So really the first part, this is the part that I've actually tested and it actually works, is it's gonna create group-owned ERC-721 tokens. So these are the non-fungible tokens. And ERC-721, this is just the most popular NFT token standard. And notice that it says in a turn-by-turn way. And so the key function that we're going to be focusing on is collaborative mint. So let's take a look at the code. So instantly at the top, you see that I'm importing some files. And these are actually from a library that's online. It's called Open Zeppelin. So let's take a quick look at that. Right. So Open Zeppelin contracts. So notice that this is just a library, and notice that for the most part, these smart contracts that are on here are pretty much vetted and relatively secure. So this is code that I don't have to reinvent the wheel when I'm doing my token implementation. So here, what I did was I went to contracts, I went to token, I went to 721 ERC 721. And I actually imported the relevant files. So notice that they've already done all the work for writing this implementation of 721 tokens. And it gives me access to functions like safe transfer from, it gives me approve. So these are all the functions, owner of, balance of, that I get access to by importing these files. So if we go back, I actually imported some extensions. So I imported ERC 721 URI storage. And what this does is it allows me to, let's take a look. Let's pull it up. Yeah, really what this allows me to do is it allows me to store that link to IPFS that actually holds the image. So I'm not putting the image on the blockchain itself. I'm putting a link to the IPFS image file. And that's where I'm storing the image. Because if I were to try to actually store the image on the blockchain, that'd be too expensive. But just one string, the URL, is actually a lot cheaper. Also, you'll notice that I'm also importing this ERC721 holder file. And so what this does is it just makes it so that this smart contract is able to hold NFTs. Because if I didn't have this, then this particular implementation would deny my smart contract from receiving NFTs. And this is kind of bad because I actually need the smart contract to hold NFTs since it's basically group owned and there's no particular owner or artist that's holding the NFTs. We just have it in our smart contract. All right, so let's take a look at the constructor first of all. So notice that, okay, it validates the amount of owners, and then we have our token counter. So this is referring to how many NFTs have been made. So we start off with 0, and then we have our number of owners, which is going to be the length of the owners. And notice that it has current owner. And so this current owner it's using the index. It's using the index of, basically this is the zeroth owner's turn to submit an NFT. And so whenever we have another turn, this is going to increment and it's going to go in a loop. For example, if we're only 2 players, it's going to go to player 1, then player 2, player 1, then player 2. So this is merged. So that's referring to, is it a composite NFT? We're going to go into a little bit more later. And notice that here I'm pushing into a public array. So here's my public array of owners. And for each owner that I have in the array that was given to me when I was constructing this collaborative minter, I was adding it to the array. Any questions on the constructor? Okay, cool. Yeah, just to point out, notice that Solidity it kind of works with inheritance. It works with inheritance. So notice that we're inheriting from these 2 files that I imported. So I'm going to say collaborative minter has access to all the functions in URI storage and can also hold NFTs. So that's one important thing to note. So now I can go to the collaborative mint function. So this is the NFT minting where only the current owner can mint. So notice that right now, when we start the game, the first owner in our public array is able to mint. So that's the current owner. So notice I actually have this modifier. So notice that whenever I'm calling this function of collaborative mint, I have only current owners. This is a function modifier. And what that allows me to do is it allows me to have this require statement in that function. And it says, okay, is the person who is submitting the transaction the message sender? Are they the person whose turn it is? And the way I check that is I check the array with the index that I have in the current owner, current owner public field. So then let's take a look at collaborative mint again. So what I'm going to do is I'm going to have a new item ID, and that's just what our token counter is. And then I'm going to call this function from the 721 implementation that I linked to that I imported from Open Zeppelin. Whoops, went too far. So I'm going to mint this, and I'm going to give it to this smart contract. So this address of this, so this is the smart contract. And then I'm going to give it the ID as well. And then what I'm going to do is I'm going to set the token URI. So I'm going to set the link, the IPFS link, and give it to that ID. And then what I'm going to do is I'm going to increase our token counter. and I'm going to set the next owner ID. So notice that I have modulo here. So it's going to go in a loop from, in this case, let's pretend I had two owners, owner 0 and owner 1. Then this will go 0, 1, 0, 1. And then I'm going to update our public field or current owner to the next owner ID. And then I'm going to return the newly minted ID, the token ID. Any questions on collaborative mint?
Like, could you clarify again, like, what does the set token URI does?
Yeah, so what a token URI is, it's basically a link to where the image is actually held. And so what this is I'm basically saying that this image that I have, this NFT that I have, its token URI is going to be the link to IPFS, and I'm just updating based off of the link that I have. It's going to be the parameter that I pass in, token URI. I'm giving the link to IPFS here, and I'm setting it to that NFT. So now whenever you look at my NFT, it's going to link to that IPFS link, and it's going to be able to render the image file. So that's how, for example, if we looked at the example on OpenSea, what OpenSea is doing here is it was able to render this image because it had a link to IPFS, and that was from the token URI. Otherwise, it wouldn't know what image to display.
Okay, yeah, that makes sense.
Any other questions about collaborative mint? Okay, cool. So let's go back to where we were on the slides. Yeah, now we're going to take a look at the merge the sequence of NFTs into a composite NFT. Notice that this is untested because I'm going to be testing that this week. Basically, collaborative mint tested and works well. The rest of it hasn't actually been tested yet, so that's why I have a caveat. So let's take a look at the code. Merge collaborative NFT. So what it's going to do is it's going to take in a link, an IPFS link to the composite NFT that I make. In this case, the implementation would be in JavaScript. I would need to, for example, if I were to make an implementation, that would be something like create a canvas, take each image that I already have, and then combine images on the canvas, upload to IPFS. And after uploading to IPFS, then I would call function with IPFS link. So that would be how I would actually implement that. In my app.js file. But here, notice that we have these modifiers. So first checks, okay, has something been minted? So you can't merge anything that doesn't exist, so that's why you have that. And now this checks, okay, is it not merged? So let's look at that. Oops. Has not, what has been, there we go. So here is required token counter greater than 0. Is not merged. It's checking that public field to see whether or not it's merged. And so this require statement is going to give an error. So for example, if I had already merged it, then I'd get an error that said, okay, the NFT is already a completed composite. So going back here, and then we have all owned by contract. So this is important because what this function is going to do is it's going to, like I mentioned before, if I go back to the example, it's going to go one by one and burn each of the NFTs that made up the collection, and it's going to make a composite one. So it's going to be important to make sure that this smart contract, like none of the individual pieces have already been sold. So that's what that's checking. So if I look at all owned by contract, so notice that we have a for loop and we're going through all the NFTs that we have, and it's checking with a function. Okay, does the smart contract actually own this NFT? So that's what that's checking. And now we're going to set the field to true if we actually came into this, and we're going to burn all collaborative mints using the burn function that's came with our implementation. And so for those wondering, so burn, what this does is send to the 0 address. So this is just an address that nobody owns. So all the NFTs are going to be sent to this address that nobody can ever access, and that's what we call burning. And then what it's going to do is I'm going to call collaborative mint with my URL. Notice that I made a function here, a private function, collaborative mint, and it basically does the same thing as collaborative mint here, but it doesn't change the status of whose turn it is, since I don't need to worry about that since the smart contract is making the change. So that's merge collaborative mint. Any questions about merging? All right, cool. So let's go back here. So now we're going to take a look at authorizing sales and distributing profits. So we have this concept of a sales transaction. So I actually made a struct up here. So it has from whoever the buyer is to the recipient of the NFT, token IDs, the NFTs that are being bid on. And then we have the value, which is how much money is being paid for the collection. And then here it checks to see, okay, is it a secondary sale? Has this been revoked? Has this been executed? And then also how many confirmations do we need? Sorry, this is actually how many confirmations do we have? So the confirmations that we need is going to be the total number of owners, and the number of confirmations that we get is going to be 0 at the very start. Notice that we also have a public array of all sales transactions. So I call that sales transactions here. And then I also have this mapping. So this mapping is basically saying, okay, give me a sales transaction ID. And then with that, I'm going to check to see has an account confirmed it or not. So it says here, check if the transaction is confirmed by an owner. So let's look at the submit sales transaction function. So this is a payable function, meaning that Ethereum can be sent to this function and to the smart contract. And then we have owned by contract. So this is saying, okay, do we actually own this for us to be able to sell it? It's going to take all the token IDs, so we can look at that quickly. So notice that this again is using the is approved your owner, which is, okay, do we actually own this? And so what we're going to do is we're going to push to our array of transactions, sales transaction, and notice that we're inputting our fields. So we have a recipient here. We have our token IDs that are coming in as inputs. We have the message sender. We have the message value, how much Ethereum was sent. And then we also have, okay, this is a primary sale. It's not a transfer. And it hasn't been revoked, it hasn't been executed, and nobody has approved it. So it's going to have 0 number of confirmations. And then we're going to return the index of the sales transaction. And then we also have approved sales transaction. So we have this modifier, only owner. And what this only owner does is it makes sure that we're in the array of owners. So here we have a mapping for is owner. So let's take a look at that. is owner, it takes in an account and it says, okay, yes or no, you are an owner of the smart contract. So that means that you're one of the artists that contributed to the work. And then we also have a couple other modifiers. So sales transaction exists. Does the transaction actually exist? Has it not been executed? Has this owner not confirmed it? Has the user not revoked this sales transaction? So then we're gonna update our mapping to say, okay, this message sender, this owner, this artist has confirmed this transaction index sales transaction. And then we're gonna increment the number of confirmations. And then if we have enough confirmations, we're going to execute the sales transaction. So we can take a look at execute. So this is a private function that is actually going to allow us to carry out the transfer and the sale. So what it does is, okay, we're going to take in a transaction index so that we know which sales transaction we're working with. And then we're going to take a look, okay, what are the IDs, what are the NFTs that are being bought? And this is referring to, is it a secondary sale or not? So if this is not a secondary sale, then we're going to do this. So what we're going to do is we're going to determine how much money to pay to each owner. So we're going to take the money that was sent with the purchase, with the transaction, and then we're going to divide it between all the owners. And then what we're going to do is we're going to, for each owner, we're going to send that amount to each owner. And this is one of the ways that you can send Ethereum from a smart contract. So you do, okay, this is my account, and then I'm calling, and I'm setting the value. So the value is how much Ethereum to send, and here I've calculated it. And then if it doesn't succeed, then it's going to say, okay, transfer failed. So that's a primary sale. Let's skip the secondary sale for now. Before I continue, any questions so far?
So when they sell, then like, so for a transaction, does it mean like it's only sell for one NFT or like all of them?
Yeah, that's a good question. So let's take a look at the struct. So here we have token IDs. So for example, let's say I'm a collector and I only value, let's go back to the example. I only value 0 and let's say the first and the last. Then I can submit an array, which could be like 0, comma, in this case 3. And I'm only gonna get those 0 and 3 NFTs, like that index, those indices. Does that make sense?
Okay, yeah, but we're still paying all the contributors the same amount, like no matter which token ID are selected.
Yeah. So whenever there's a sales transaction, for example, let's pretend 0 and 3 again. I'm sending Ethereum with this transaction for the dual purchase of those 2 NFTs. So there's only one payment that is made. And so that's why I can divide it between all the owners. So each artist is going to get a cut for 0 and 3. So the idea is, even though you may have not yourself made the individual NFTs, these are collaboratively owned NFTs. And so you're going to get profit from any NFTs that are sold.
Okay, got it.
Yeah, if I wanted to say, okay, you only get money for the ones you made, then I think that would make it a little bit like less collaborative, in my opinion, because these are professional artists that are collaborating together. Like these could be professional artists, right, that are trying to make a living.
Mm-hmm.
So to incentivize them to want to collaborate, and I think it makes sense for them to not have to worry about their own NFTs selling as opposed to any NFTs selling.
Right.
Any other questions? Okay, cool. So that's the first part. That's getting the owners paid. But then we also have to do the transfer for the NFTs. So for each NFT that we have, we're going to be sending it. So we're going to use a safe transfer function. We're going to transfer from the smart contract that owns the NFT. We're going to send it to the recipient that we have in our sales transaction. And then we're going to send whichever NFT that we indicated. This code may not be correct. I had to double check that, but I think it, yeah, I think it, yeah, it looks good to me right now. Yeah. And then what it's going to do is it's going to update the struct, say, okay, this transaction has been executed, and then it's going to return true. So that's executing a transaction. And we also have a deny sales transaction. And what this does is it just removes the confirmation. It changes it to false for has this owner confirmed transaction. And we also require, okay, have you confirmed this before? So that's this required statement right here. And then we also revoke sales transaction, because one thing about the smart contract is that whenever you submit a sales transaction, the Ethereum you sent gets locked into the smart contract until there's approval from the artist. So then that could mean, for example, let's say you submit a bid for 10 Ethereum, then your 10 Ethereum is going to be locked up until until the artists decide to execute the transaction or not. So let's pretend that you change your mind, or for example, you don't get a response from the artist, then you should be able to revoke that. And this is what it does. What it does is it basically just returns you your money. So it's going to say, okay, how much Ethereum did you send us? And it's going to send that to the message sender. Yep. And then it's going to tell you whether or not it failed. And then we're going to say, okay, it's been revoked. So that's pretty much it for, let's see, did I miss anything? Yeah, submitting, approving, denying, and revoking. And then it comes the part about implementing royalties from secondary sales. So this may or may not work. This is, I need to test this a little bit more. But essentially what I was trying to do here is I'm overwriting these functions that I got from the 721 implementation. So 721 implementation from OpenZeppelin, it has a save transfer from function, and it also has a transfer from function. So I'm overwriting those and I'm making my own so that I'm able to actually have royalties. So what I'm doing is, so notice I'm using override, and what I'm requiring is, okay, do you actually own this? And then I'm creating a secondary sales transaction. I'm sending the NFT to the smart contract, and then I'm going to execute the secondary sale. So here we have a token ID array, which ones, in this case, I'm only allowing one transfer at a time, so one ID at a time. And then I had to change it into an array for this to work. And then I'm submitting a secondary transaction, which is pretty similar to the submit sales transaction. So let's take a look at that function. Yeah, so you'll notice that we're also submitting a new sales transaction struct, except this time we have secondary sale is true. And then we're going to transfer the NFT to this smart contract. And then we're going to execute the sales transaction, so we can take a look at that. Let's roll. Yeah, so now we're in this part of the if else statement. Okay, so now we have a secondary sale here. And so what we're doing here is we're going to apply the fee. In this case, I said 10%, but it could be something else. So we're saying 10% goes to the owners. And then we're going to divide that 10% of royalties between all the owners, and we're going to send it. And that's the idea behind secondary sales. Now, I also have to do that for some of the other functions that are in the implementation. So notice that there's two save transfer froms depending on how many inputs you give. And there's also a transfer from function. And I had to override all of those. Otherwise, users would be able to avoid the secondary sale royalty fee. So any questions about secondary sales? All right, so that's pretty much the overview of the backend. So I've gone through the factory, which is creating the collaborative minters. And then I've gone over the collaborative minter itself, which is doing these 4 things. So it's creating the 721 tokens. It's allowing you to merge them if you'd like, authorizing sales, distributing profits, and it's also implementing royalties. So like I mentioned, the code might change a little bit, but I think for the most part, it's going to stay relatively the same, or at least the concept of the code is going to stay the same. One thing that I might get in trouble for when I'm doing testing might be, for example, the execute function. Since I haven't really tried it yet, I'm not sure if it's going to work the way I want it to, especially since I'm not used to sending Ethereum in this manner, so I'll have to see if it actually works. So now what we can do is, if there's no questions about the back end, the blockchain aspect of this, then we can start looking at the front end code. So let's take a look at that. All right, let's look at this. So really what the front end does is it allows you to connect to MetaMask. It creates collaborative minters for you. It reads information from the collaborative minter that we set, and then it allows us to call the functions from the collaborative minter. So let's look at the connection part first. So yeah, this front end is implemented through React. So notice I have import React, and I'm importing useState, useEffect, and useReference, useRef from React. And then we're also using this library, web3.js. So I'm importing that as well. And then what I'm importing as well is the ABIs, the interfaces for both of my smart contracts. And I'm getting these from Truffle. So I'm using Truffle to compile my smart contracts and send them to the blockchain, in this case, the test network. And so we have the interfaces here. So that's telling my front end, I'm telling my JavaScript code what smart contract methods and functions are actually there. And then I'm also using jQuery for the IPFS aspect of this. So here, notice that I'm using this JavaScript library, IPFS HTTP client, to access IPFS. And I'm also creating a connection to this host, this Infura IPFS host that I'm using to actually interact with and upload files to the IPFS system. So let's take a look at the load blockchain aspect of this. So here we have startup. So I use useEffect to do this once at startup. So I'm going to have load web3. So I'm going to create a new web3 instance on this window. And notice that if it's not supported, then there's going to be an error. But otherwise, we're going to be able to set MetaMask or other Ethereum provider, which is this aspect over here, window web3. And then I'm also going to load some blockchain data, which is going to be the accounts. So I'm going to await the accounts, and then I'm going to, for one of my state variables, I'm going to set the value of account to the account that's set on MetaMask. So I'm setting my account, and I'm also displaying that. So if I scroll down to my HTML code, here I have user address, and I'm reading from my state variables, I call it values. So my state variables values that count. And that's going to show you the address for your that is connected to the web app. So before anything, I initialize state variables here. So here I have values, I have set values, and I'm using state. And notice that if something happens, then we're just going to get a message connect an Ethereum account. And then we also have a variety of other state variables. So that's the first part of connecting to MetaMask. And we have the create collaborative minters aspect. Well, let's take a look at the interface again. So basically this part up here is just reading from my state variables. This section here. Then we have find factory root address and then find commenter root address. So if I go down to my HTML code, notice that we have here, so we have find commenter root address, this is the button, and on click, we're going to call this function handle find commenter, and we also have find factory root address. So let's take a look at handle find factory. So here we have a function, and what it's going to do is, we're going to reference, let me go back to that. So notice that both of these has a text box. So in my interface, notice I'm setting the address here. And so the way I get the value from the text box is I'm using a reference. So in this case, I call it find commenter ref or find factory ref. And I had to initialize that before. So if I look at find factory ref, for example. Here's my initialization for references for text boxes. So I just say, okay, use ref for this. So I get the current value inside the text box, and that's my factory address. And then I check to make sure that this is actually a number. So remember that 0x, this is a hexadecimal number for the address. So I'm checking to see, okay, do we actually have a number? And then I'm going to call this function, I made this function add factory contract. And so here I'm saying, okay, let me get the interface and let me get the instance of Web3. Here I'm using try because I'm not sure if the user gave me a valid address. So I have it in a try and a catch block just to make sure that if there's any errors, the app won't crash immediately. So here it's going to say, so imagine if there is an error, then it means the smart contract didn't work. So it's just going to say, okay, input a valid factory address. So if I give a bad input, that's just going to tell me. But otherwise, what it's going to try to do is it's going to try to, this is how you add a smart contract by address and by interface. So we call this function, the Web3 function, with the interface and with the address, and then we test to see if it's valid by calling, I called one of the functions that I have. So I called collaborative minters of 0. So if we go back to here, so collaborative minters, this is a public array. And so each public field actually gets a function attached to it, a getter function. And so I'm just calling the getter function just to see if it actually works. And if it does work, then we're going to set this factory contract, the state variable, just so I have it on screen. And if it doesn't work, like I mentioned, it's going to say input a valid factory address. And then so we're going to call that function that I defined, the asynchronous function, add factory contract. But if we're not given a number, so remember I checked to see, okay, did we get a number? If we're not given a number, then we're also going to get this input a valid factory address. And so handle find commenter works in a very similar way, except it does a couple of different checks that are a little bit different. So I can go through that. So here we're reading from the text box, find the commenter, the text box that we have. And then again, we're doing the same thing. We're checking if we have a number. And now I'm checking to see, okay, if we have a commenter, then we're going to see who's the current owner. We're going to check to see who's whose turn is it, whose turn it is. Then we also see, okay, how many tokens have been made, and then we have how many owners do we have on this project, and then we're going to update the state variables with that information later. Notice that these are all awaits because I have to wait for the blockchain to actually give the information. So in this case, Ethereum. And then I also have, okay, I also have an array, of the index owners, and I'm pushing those as well. So then now I have my updated state variables, but if there's an error, then we're going to be told, okay, input the right address. And again, if we weren't given a number, which is an address, then we're going to be told that input a valid co-minter address. And so that's how we do the first part of find the co-minter with address and find the factory with address. Then there's also create co-minter. So we have handle create co-minter. And so here we're checking to see, okay, do we actually have a factory contract that's been set? Because we need to know the factory contract, where it is on the blockchain for us to be able to make a collaborative minter. And then we have a log as well, which is sending messages. So we have a add to log function, which is sending messages at the bottom of our screen. So our message log down here. So next we're gonna have our owners, and we're using JSON to parse the value in the text box into a JSON object. And then what we're going to do is we're going to initialize, okay, Web3 again. We're going to get the factory contract ready from our state variable. We're going to just deploy a new collaborative minter using our function. Notice that we have a factory contract. We're calling one of the methods, create collaborative minter, and we're passing in our array. And here, notice that this is send. So we're sending a transaction to the blockchain, which is this call to create collaborative minter. And inside, we're sending from our account. So this is from our Ethereum account, we're going to send this transaction, and then it's going to give us an error, or it's going to give us a result. And then if it works, then we're going to continue. And then we're going to get the number of collaborative minters. We're going to get count to co-minters. We're going to get all this information from the new co-minter that was made. And then notice here that I'm getting the interface, the Minter API. And I'm going to check whose turn it is. I'm going to get the tokens that have been made and the number of owners. And with that information, what I'm going to do is I'm going to set the state variables. So that's pretty much an overview of the create co-minter function. That leaves us with load co-minter. So we have handle load co-minter. Any questions before I move on?
So which address should the user input for a factory address?
Yeah, factory address. So in this case, they would need to know like where I deployed it to, like on the Wikipedia.
Oh, okay.
Yeah, in this case, if I wanted to, I could automatically preload that into the file. But in this case, since I'm still doing it in testing, then I just have it like on a notepad, for example, here written down. Like this is where I put it on. It could be. This might be useful, for example, Tony, if I update the factory contract in the future. And then let's pretend I have version 1, version 2, version 3. And let's pretend it's on Etherscan. Then on Etherscan, let's pretend I have like it would show up when I wrote collaborative minter, and then it would show me version 1, version 2, version 3. So that's how that would work. if I wanted to make this updatable, then I would need to be able to set the factory address, and that's the only way you could do that.
Okay.
Any other questions? All right, cool. So we'll look at handle load commenter. So here we check to see, okay, do we actually have a commenter contract that's been loaded? Otherwise, we get a message to our log. And we're gonna get the factory contracts from our state variable and the commenter contracts, again, from our state variable. And we're taking a look at, okay, how many, this is a typo, I need to fix that. I'll fix that later. Yeah, this should be commenter token count. Okay, cool. So now we're beginning to display token URIs. And what this is going to do is, okay, we're going to go through, we're going to call the function token URI, which is a public getter function for the link to our image file from our NFT. We're going to call that. I'm going to display it to on our log, and using some jQuery, I'm going to get it from IPFS. So I'm getting the images here, so I'm displaying them. So what I'm doing is adding a sequence of images to DOM. I'm showing the turn. I'm gonna have a turn number. So what it should look like is, for example, it's gonna be turn 0 and then image 0, and it's gonna say, okay, turn 1, image 1. It's gonna have that sequence. So it's gonna append that to the DOM. And notice that here it's right here we have the image URL. So we're getting that from, let's take a look. Image URL is coming from here, data.image. Okay. And then that's going to be the source for our image that we're displaying on screen. So notice that we're appending this to the DOM, and we're adding to the log the link to the IPFS image file. So that's how you would display from IPFS the images that we have. So that's load commenter. So what it does is it just shows you all the different stages of turns that have already been played. So in this case, it would be, in my example, if I go back to that, it would render on screen turn 0, and then it would show like this piece of artwork, and then it would say turn 1, and it would show this piece of artwork, and then it would keep going through every turn that has been submitted. So that's what load commenter does. So let's take a look at this. So then we also have, for example, loading the picture. So I could go do that if you all want. So yeah, let's take a look at that. I think it's called file submit. Yeah, so here we have capturing a file. We have on file submit. We have name of your work, description of your work. So this is this section right here, which is submitting to the commenter. So let's look at capture file. So this is processing the image for IPFS. So whenever there's a change, we want to prevent a default. We don't want the app to crash, so we're going to prevent default. Next, we're going to get the file, and we're going to start to process it, and we're going to read it, and we're going to convert it into numbers, our image file to numbers. And once we have that, we're going to put in our state variable, our buffer. And once the user is ready to submit the file to IPFS and submit it to the commenter, it's going to send the image to IPFS and then submit it to the commenter. So here, what it's going to do is, again, prevent a crash, prevent a default. And what it's going to do is it's going to check to make sure, is it our turn for our commenter? So if it isn't, it's not going to let us continue. It's not your turn. Otherwise, it's going to submit the file to IPFS. It's going to wait for the link. And what it's going to do after that, it's going to create the collectible by calling the commenter contract. So here we have a base description. So this stage of the artwork was submitted by this account. And then we have the image URL. So here I have the base of the URL, and then I have the result path. So I got that from the IPFS library that I'm using. And then we have the image URL. And then we have the name that we have in the text box. And we also have the description. So if they add anything, it's going to be added on to that first sentence of who contributed this piece of artwork. And we're also logging the description, for example. And we also need to create a metadata file for IPFS. So the metadata file for the NFTs is going to hold 3 different things. So it's going to have the description, the image URL, and the name. So we have to create that. So now what we're going to do is we're going to submit that JSON to IPFS. And that's going to be what's this JSON, this metadata JSON, that's going to be what becomes our token URI. So whenever we think about a token URI, we're thinking about this JSON that holds the image URL, the description, and also the name. So then we have our metadata result, and we turn it into a URI with the base of the URL here. And then we add it to the log. And now we're actually going to create the collectible itself. So here we have, okay, this is my new token transaction. So we're going to call collaborative mint with this metadata JSON URI. And we're sending it from our account. And then we're going to update the state based on those smart contract values. So now we're going to, again, read from the commenter, what's the next turn, what's the new token count, that kind of information. And then we're going to update our state variables to reflect okay, what's the new IPFS hash that we made, also whose turn is it, what is the new commented token count. So we're going to have that information. And then I also had this other function, which is display latest IPFS, which is for debugging. So I won't go into that. But yeah, this is a whole process of getting the URIs, getting all the files up to IPFS, and actually sending and calling the collaborative mint function. So notice that really what's on the blockchain is just a JSON file, a link to a JSON file. And in the JSON file is, again, just a description, an image, and a name, and that's our NFT. Any questions about this process of submitting a file and submitting a turn, actually? Submit to the commenter. Okay, so then the last part is going into the authorization of transactions. So like I mentioned, this is still a work in progress, so I haven't actually written all of this. I have, as you can see here, I just have the interface set up. So I need to write these functions. I'm probably going to write them tomorrow. But yeah, I mean, I have a section here, which is going to be allowing you to transfer an asset, allowing you to create a transaction, allowing you to manage transactions that are already listed on the collaborative printer. And that's basically the whole walkthrough of my project so far. Do y'all have any questions, feel free to ask. Otherwise, that's pretty much all I have for y'all today.
I don't have any questions, but that seems to put a lot of work into it. Really good.
Cool. Thanks, Kartik. Appreciate that.
Yeah, I feel like I really learned a lot. It's like building an app like in 1 hour.
Yeah. It did take a little bit longer. I didn't know how long this walkthrough was going to take, but yeah, like I mentioned at the start of this is all on GitHub. So if y'all want to check it out, my username is Guadiana100. So it's all on GitHub. And also what might be of interest to you all is my README where I'm putting my references. So for example, I based a lot of the transaction stuff from this multi-signature wallet and some of the functionality from this simple open auction example. And then another multi-signature wallet up here, an NFT contract here, tutorial, just a bunch of different random stuff. Like for example, I didn't know how to have one smart contract create another. So I had to look at the tutorial for that. And then the links are down here in the references. So if you're like, oh, I have no idea how he learned React in 30 minutes, then boom, right here's a link on 5. So that could also be useful for you.
Yeah, for sure. How long does it take you to like do all these?
Oh man, how long does it take me? A long time. I've been working on this aspect of the research project for maybe the last 3 weeks or so.
Okay.
But yeah, like for example, if I look at, this is my whole research repository, so I can show you what I've been up to. Like first I did this tutorial, this truffle tutorial. So first I did this Python tutorial. So if you want to learn how to do stuff with Python, then you should check out Patrick Collins tutorial number 2. And then I did the truffle then I did the collaborative art tool. That took me a long time because I kept messing up. But eventually I figured out how to make it work. And then I kind of got annoyed at Python because I was getting mixed up with the backend and the front end. I was trying to make some of the Python backend be part of the front end, and it was not working out. I would recommend not trying to do that in the future.
Like if it's a dab, then like we can just use Solidity, right? Like, what's the point of using Python though?
This is I can show you, right? I mean, basically what this does, Tony, the Python, it allows you to have these scripts. So for example, create collectible, create metadata, create advanced, like it has that information for you. But the way I'm using it now is I'm just using it. For example, I have my files here. I'm using it to deploy to the blockchain.
I'm not seeing anything. Are you trying to show something right now?
Oh yeah,
like
apologies.
I think the screen is freezing.
Can you all see now?
Yeah.
Okay. So we have a NFT brownie tutorial that I was looking at. So there's these scripts, right? So in this case, I have my contracts, and you know how Truffle allows you to deploy your smart contracts to the blockchain?
Yeah.
You can actually do that through Python. So that's what I was using it for. So see how it says, let me see, deploy. Let me try the simple one. Deploy simple. So it says, okay, from this key, deploy this, in this case, collaborative minter factory.
So what's the difference like with the JavaScript one?
Tony, you're getting confused. So yeah, that's why I was getting confused too, Tony. That's why I was getting stuck. So getting the smart contract to the blockchain is not part of the front end. So for example, when you download Truffle and use Truffle to deploy, it's doing something very similar to this. So your deploy like from Truffle can be replaced by deploying from Python with a script.
Oh, yeah. Cause I remember like when we used Truffle, like we did have some like code like this, but it's like in JavaScript.
Yeah, yeah, and so where I was messing up, Tony, is that I was trying to trying to have my front end be also in Python,
Mhm.
but like there was no reason for me to do that. I could have just done the front end in JavaScript like I did
Yeah,
app.js.
right.
But yeah, if you're more curious, I would just check out the tutorial because it was actually pretty cool.
Mhm. Yeah.
Any other questions before we log off?
I think that's all the question I have.
Cool. Karthik, you good?
Yeah, I'm good. I'm good. Thank you for everything.
No problem. All right, well, have a nice night. Take care.
Yeah. Thank you.
See you.
Bye.
Bye.